Okay, again, today we're going to be looking at the law of conservation of mass with some more. And today we're actually going to be trying to balance some chemical equations. This schedule for this week is tentative. We might be moving the exam down to Friday depending on how far along we get today. We may have to extend today into tomorrow a little bit. Okay, so today we're going to be looking at the law of conservation of mass. Can somebody remind me, what does the law of conservation of mass state about mass? 2 words. It was your vocabulary and it was the clue words. Mass cannot be destroyed, or somebody just said it, created. So in a chemical reaction, mass cannot be created or destroyed. The atoms only do what? Move around. Remember, the bonds break, the atoms move around, and new substances form. So, keeping that in mind, remember, if no mass is created or destroyed, the mass of the reactants and the mass of the products have to be what? The same. They have to be equal. So, keeping that in mind while you do your warm-up there, while I do attendance. Okay? Was Gracie at practice?
No.
Also, your grades are posted. You have till Friday to get any missing work to me. And there's lots of missing work, unfortunately. Okay, as soon as you've seen yours, move away. If you have missing work, you come talk to me. Okay, let's go over this warm-up. You'll have a seat. These were both in practice. I did not take grades, but I will check in the morning. Okay, on the warm-up, it says if 56 grams of a solid magnesium, here it is, 56 grams of the solid magnesium reacts with 32 grams of hydrochloric acid to produce 25 grams of magnesium chloride and hydrogen gas. What is the mass of the gas during this chemical reaction? So how much gas would be produced? Anybody work that out?
I got 37.
You got 37. What did you get? 63. Okay, how would you do this? It is a simple algebraic solution. What would you have to do these two? So everybody add 56 and 32, please. and that is
88.
88. Okay. Now, 25 plus what is equal to 88? And it would be 63. So again, here are the reactants. That is 88 grams total. That's going to be equal to the products. We have 25 of this. How much of this do we need? It is 63. 88 minus 25. Everybody see how to do that? Those have to be equal on both sides. Remember, we talked about this arrow being also an equal sign. Okay? Any questions? Okay, put that away and get out the sheet from Friday. Analyzing chemical equations. That looks like this. I'm going to go over this with you. Make sure you follow along and are understanding. This was to determine whether each of these is balanced or not. Okay? So it was just a matter of counting atoms. Nobody turned it in because the box is empty. Okay, so the reactants, CH3 plus 2O2. The product, CO2 plus 2H2O. I hope everybody has it out and is following along. Here we have to count, so we have to put some ones. There's one C, 3 H's, and 4 O's there. Again, that's just counting at this point. Everybody should be able to count. 1 C, there's 2 O's, plus 2 O's over here is 4 O's. Okay, and the H's is 4. Are the H's equal? Is it balanced? No, it's not.
Unbalanced.
Hydrogens are unequal. The hydrogens are unequal. Okay, on the next one, 4Fe plus 3O2, 2Fe2O3. We have 4 Fe's, 4 times 1, and 6 oxygen, 3 times 2. Here we have 2 times 2 is 4, and 2 times 3 is 6. Are those equal?
Yeah.
They were equal. You should have gotten that as balanced. Okay, on the next page, 2Ag plus S, Ag2S. 2 times 1 is 2. 1 times 1 is 1. 1 times 2 is 2. 1 times 1 is 1. Are those equal? Yes. That was balanced. Okay, on this one, we have 6, 12. We have 6 here and 12 there, for a total of 18. We have 6. 6 times 2 is 12. 6 times 1 is 6 for 18. 6 times 2 is 12. This one was also, yes, it's balanced. 5. CO2 plus H2O will give you C6H12O6 plus O2. We have 1 carbon, 2 oxygen here, a 3rd one there, and 2 hydrogen. This is just obviously no. Yes, sir.
On that first chemical formula right there on the left, what if you put at the end we put plus E? Is that okay?
Where's that?
Right there at the top it says CO2 plus H2O plus energy.
Right.
So like on that.
Did you list energy here?
Yes.
That's fine.
Okay.
It's not, energy doesn't have mass, so it doesn't play a part in the law of conservation of mass. So if you left it off, it's okay. Okay. Okay, on this next one, long and complicated, 2NaHCO3 plus CH3COOH, CH3 3COONA plus H2O plus CO2. Okay, we have 2 NAs there. And how many here? Just 1. So that's all we had to do. Now if you counted all of them like you should have, you would have got, here's an 1H, 3, 4 H's. For the carbons, there's 1 there, and 2 there, 1 there, and 1 there, so that would have been 4. And the O's, there are 6, 7, 8. Anybody anything different than that?
Wait, I think I got H's.
The H's, there's 2 here. Oh yeah, you're right. Thank you. 2, 5, 6. Should have been a 6. I do make mistakes. Is that what you got?
Yeah.
Okay, you caught me. Sorry.
Alright.
Way to look. Did anybody else see another mistake there? Because I make them. I'm human. Okay, for H's, here's 3, 4, 5. So I think the H's are 5. Carbons, 1, 2, 3. O's, 1, 2, 3, 4, 5. Anybody get anything different? Because I might have made a mistake. Okay, then that was no. Okay, on 7 and 8 on the back. Hopefully you got a chance to do this. 2C plus O2, CO. That's 2 C's and 2 O's, 1 and 1, so this was no. The last one, SiO2 plus 2C, Si plus 2CO. We have 1, 2, and 2. Here's 1, 2, and 2. Why 2 and 2? Because 2 times 1 is 2, and 2 times 1 is 2. Questions? Okay, that one was practice. Today we're going to find out when they say no, how you make them say yes. So everybody turn to number 7. Turn to number 7. Okay? We need to make this say yes, it is balanced. Any unbalanced chemical equation must be balanced. Otherwise it does not follow the law of conservation of mass. Okay? So, keeping that in mind, we are going to have to change the number of atoms in this chemical equation. Okay? Now, if you remember from our notes last week, what can we change and what can't we? You can only add coefficients. Very good. We cannot change subscripts. We have 2 carbons here. What are we going to have to put in the front right here to make it 2 carbons? We're going to have to put a 2. So, on your paper, I want everybody to put a 2 right in front of it. Okay? Put a 2 right in front of it. That would make this a 2. How would that change these 2? And then suddenly it's what?
2, 2.
And it's a yes. That's how you balance it. Does everybody understand? Okay, let's take a look at another one that said no. Okay, on the front, number 1 was a no. Okay, where you want to start is anywhere really. Okay, so you can look at any of them that are unbalanced, and here it's the H's. The H's are unbalanced. Okay, we have 3 on this side and 4 on this side. So we're going to have to make them equal some way by changing coefficients. Okay, let's start. This is, why did I choose? This is a hard one. This one's very difficult. We're gonna wait on this one. Let's go to another one. Okay. Well, let's do it. Let me get a different sheet of paper though. Because sometimes these are difficult even for a teacher. So we're going to see if Mr. Klump can do this. Hopefully I can. but you're going to see that this can be a little complex. Okay, so we have CH3 plus 2O2 yields CO2 plus 2H2O. Okay, what we have to try to balance here is our hydrogens. Okay, our hydrogens are not right. Okay, this is just a matter of trial and error. You just have to try some things. Okay, if I needed same hydrogens, I could put a 3 here, and that would make that, how many let's do a 2. 2 there, 2 times 3 is 6. Okay. What could I put here instead of the 2 to make this 6? We could make this a 3, and that would be 6. But now that changed the oxygen. We now have 3 oxygen here. We have 2 oxygen here, for a total of 5. Okay, is there going to be any way to make 5 oxygen over here? No, because if we change this to a 3, it's going to be a 6 oxygen. So we might have to change something else. Because we put a 2 here, that's changed the carbon. So what are we going to have to put right here? A 2. That makes the carbon 2, but that makes this 4. Now we have 4 and 3 is 7. There's still nothing we can do to make that a 7, is there? Okay, so we're going to have to think again. See how complicated this can be? Okay. Let me show you how I did that now. Okay. 4CH plus 4O2 will yield CO2 plus 6H2O. Okay. 4 times 1 is 4. Okay. So this is something still wrong. Okay, I have it here. What's 6 plus 8? 14. Okay, now that should be it. Okay. 4 is 12. 12. 14. 4 times 2 is 8, and 6 times 1 is 6. 6 plus 8 is 14, so that's it. Okay, that took me a while, and even for me, they're a little difficult. Okay, you would never, as an 8th grader, be asked to do one this difficult. Okay, you will never be asked to do one this difficult. The ones that you will be doing here in a moment are a lot easier. Okay, but again, you just have to work back and forth until you can get it to balance, and you're just counting the atoms. What is the only thing you can change? The coefficients. Okay, each table is going to get a little Ziploc bag with some chemical formula material in it. Go ahead and clear off your desk. Yeah, that's yours. That was practice. That I'll check it for you as practice. Okay. Now, the procedure. Go ahead and clear everything off your desk. You and your lab partners are going to have to stand up and move around where you can see all the cards together.
So we can speak our lab partner?
I would just, you can move. Well, I prefer that you just stay.
I got infidels today.
Okay, objective. To read chemical equations, to identify elements by their chemical symbol, to count atoms, to identify the coefficients of subscripts in a chemical equation, to label the coefficients and products of a chemical equation, to balance chemical equations. So that will be the most difficult thing to do, is the balancing part. Okay, so on the lab today, you are going to be balancing chemical equations. On the back of your sheet, flip it over, are the equations that you're going to have to create and balance. Okay? The ones you have to create and balance. So, can everybody take out the cards and create what's on the screen there, please? And laying in front of you. Everybody rotate your chairs around where you can see the cards. Everybody on one side of the table. Create the first equation that's on your sheet. It's on the screen. Quickly, boys. Come on now. Get them out. Y'all rotate around where everybody can see it. Come around this way. Lane, pull it here, right over here where you can see it. Okay. Flip your lab sheet over where you can see it. Somebody tell me, what are the reactants in this equation?
H2 plus O2.
Everybody write that on your lab sheet. As soon as you get this made, please. You need to get them all the cards out of the back. Get them out where you can see them. I would spread them all around the other side of your table where you can see all of them quickly. Okay? Because you'll need the numbers. You'll need to be able to grab them quickly. Okay? So, on your lab sheet, up next to this equation, where it says the reactants, list the reactants. What are they?
H2 plus O2.
Very good. And then it says list the products. What are they?
H2O.
H2O. List those, please. Yeah, you're going to have to remember here. I will move all this that way. Okay. Now, look at the equation. How many, in the reactants, how many H's are there?
2.
And how many are there in the products?
2.
Very good. Are those balanced?
Yes.
Yes, they are. We don't have to mess with the H's at this point. How many oxygens are in the reactants?
2.
How many in the products?
1.
How are we going to get 2 over here? What are we going to have to add to this side?
2.
Okay, you're going to add a 2 in front. So everybody find a 2. Everybody find a 2. Now, when you add the 2 in front of the H2O, what does that do to the hydrogen? Makes it a 4. So now we're going to have to go back to the other side and make the hydrogen 4. What are we going to have to do to the H2? Add a coefficient of 2. So this is the way your equation should look. Okay? Now, where it says reactants final and products final, write the new reactants and the new products. And then write the final equation.
What about the O?
Well, the O, how many? It's okay. How many O's are over here? No, there's 2, and how many are there? So they're equal. You don't have to do anything. Okay. Does everybody understand what you're doing? Try the next one, please. Your turn for the next one.
The H2O. The last equation specifically.
Yep. Create the next equation. So just, yeah, move this stuff. Oh, you need the H2. I so told you I have the labels out where you can see them. Now hold them all in your hand. Okay, very good. Now you're going to have to try to balance it. What do you have in front of those balance now? What's not balanced? This seems easy. How many oxygens do you have here? How many do you have here? 3. So you're going to have to change this. Well, if you put 2, you have 4. Are you going to be able to change that to a 4? Probably not. I would do a 6. I mean a 3. Try it and see what happens. How many hydrogens do you have? 6. So what are you going to have to put here? Yeah. Okay. So how many oxygens do you have? 6. You have 3 here, but only 2 there. So we're going to be able to add in that to get 6. Well, that would be 6, and you'd have 9. So that's not going to be right. So you're going to have to try again. Try something different. Okay. Okay, did y'all get it? You got it? Okay. So we have 4 hydrogens. 4 hydrogens. We have 4 oxygens. 2. Okay. 6 is going to be. That one is probably going to be too much. Okay, but you can look at it. Let's not take it away. That's 12. And that's 12. That's 12. That's 6. What could you add there to get another 6? You could add a 3. So how many H's? 12. How many here? 12. How many oxygens? 12. You have how many here? Plus. Okay. Guess what you can do, however? These 6's and that 3 are divisible by each other, and you can what is called reduce this. How many times will 3 go into a 6? Twice. So get 2's and change them for the 6's. And then take the 3 away. And there's your final equation. See how to do that? It's called reducing. That's right. That's right. So you have 4 hydrogens and 4 hydrogens. Well, let's. So how many hydrogens do you have here? 4. 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. 2 times 1 plus 2, 4. So that's right. You got it.
So this 587.
Now try to balance it. It's not balanced. You have 2 here, 2 here, 2 there, but you have 3 here.
Knew it. I told you, Jay.
Okay, so try it 2 there. Start with the lowest numbers. How many do you have here now?
4.
But you only have 2 here, so what are you going to have to put there? Okay, so now you have 4 and 4. You have 4. 2 plus 2 is 4. You don't need 2. Because how many do you have over here? 4. That's it. You don't. Okay, perfect. You understood. That's right.
Yeah, that's all right.
Always start with low numbers like 2's to start and try to balance it. Yeah. Yes, keep going. Remember to write the final formula. 2. And how many do you have here? So what do you have to put in front? Put a 2 in front.
Yes.
But opposite, how many do you have here? And how many do you have here? So what do you have to be putting in front of here? To get it, you'll have to put a 2. But what did that do to your NA now? So what do you got to change this 2 to? And then you're done. And you got it. Y'all got the hang of this already. Good job. Perfect. That's exactly right. Good job. You could if you want. So I would start there. Well, wait though, because how many O's do you have there? And how many do you have here? So where do you want to put it? You want to put it there. So now your O's are right. But how many NAs do you have here? No. 4. That's exactly right. Yes, that is right. Good job. These are much easier, aren't they, than the one I tried to do? Okay, well let's do the oxygen first. How many oxygen do you have here? And how many? So you have to put a. Now what? How many NAs do you have? 4. So you have to put here. A 2? That's it. Well, you're supposed to be writing files. You're supposed to be reactants, arrow, balance equation. You'll get that one? Very good. You're missing something.
That's fine.
C2 plus H2 will yield H3. Okay, that makes 4. How many N's do you have here? You just have 1. If you put that 2 up there, you have 4. You have 4.
Give me a 2,
Now, how many hydrogens do you have? So what do you put in front of that hydrogen in C12? No, 4 times 2. You get it?
So this is not.
James, help us. No, it's not. Oh.
Okay, this one you can do something. Do something called reducing. You see how 2 will go into both of those? 2 will go into 2 how many times? 1. 2 will go into 6 and it would be a 3. 2 would go into 4 and it would become a, and that's the reduced equation. Now you
Maybe it's like 5 here. 5. We'll put 5 there either. See, I was right.
How many others do you have up here? How are you going to get 10 there?
I'm right.
So you're going to put it on.
That's right.
It's 02.
No, I said I was right.
Okay, next one.
We need a iron. That's H2O. Jake, stuff.
Well, you're adding the coefficients to make this side equal to that side. Okay. So look over here. The coefficients are the big numbers you're adding. So how many FEs do we have here? So we have to add 3 in front of it to make that one. You cannot add little.
Oh,
Okay.
because this one it doesn't have put a number in front of it.
Yeah. If you need to. Because if they're not equal, you have to put a number. How many FEs are here? So you have to put a number right that one. They have to be equal. It has to be on the other. So if this would have been a 6, which you would have to put in front of it, a 6. Get it?
Yes,
Okay.
because we're balancing it out.
That's right. Remember that equation is like a seesaw. They have to be equal. You should have 2 plus. Have to be.
Y'all are mean.
Yeah, look around because I made all these.
Guess what day
Does everybody have 2 plus signs? Does anybody have 3? You have 4 plus signs? Let me have one of them. All you need is 2. So
Pick on me all day.
thank you. They got mixed up. I knew I cut it up. Hey, you see how many C's are here? There's 1 there. Over here, how many H's?
Hologram factor.
4. There's 2 here, so we had to add 2 more. So 4. We had to add 2. They're flirting. Boys pick on girls, it's not flirting. It is Halloween. Don't stop. Mating season's over. You all leave each other alone?
Yeah, we'd be alone, right?
You got that one already?
Yeah.
Has anybody finished yet?
We got 3 more.
Put your little
How many H's there?
Safety.
How many C's are there now? Okay.
We're sorry. We're sorry. You can't.
Now you have
like
eight
follow
H's
us for that off.
eight H's there. There's
Don't bring that up. That's not okay.
That's probably how I read it. This one is 0 and 4.
Oh, I didn't read it. Here, keep it right there.
oh, keep going. You should be able to get these done before the bell. We're going to go over the correct answers. You have two.
You can't keep up.
How many NAs here?
Two.
How many you need done on there?
2.
So what do you got for quick start?
2.
Date.
Now, S's,
I know,
1 and 1. O's, 4 and 4.
That's one.
1. CL. Well, you already have it. That one was too easy. That's it? A lot of looking at it.
Don't touch it. Shady.
The other end is the last one, right? That it?
Wait, where's those
How many
eight?
NAs? How many S's? O's? That's how you do it. You have to begin and check each one.
This is the ring finger here.
That would be the big one.
I think this is
Yeah, so you're gonna have to yes. That's 3 there. So that changes the oxygen to 3.
She was a slow runner. She was slow.
The last one is difficult. Just keep working at it. You can do it.
Oh my gosh, that one before the last one. Yeah, keep, yeah, keep, but.
Let's see if you can get the last one right. It's very difficult.
The one before that was hard.
No, it's not.
That's a lot of numbers. N-A-S-O.
But you only need one coefficient to balance.
I think
Awesome. Okay, now you have 12 hydrogens. You have 12 hydrogens. You have 10 oxygens. 8. Keep going, it's not right yet.
I'll go to Santa Cruz. I'm going to Honolulu.
How many hydrogens? 6. You have 6.
So I guess I'm going to go.
Is there any way to make that O7? No, something you're going to change that to.
No.
Oh my god.
Okay, I would change that. Well, I'll change it to a 2. This one actually, you're going to have to change because you have to. Which one don't you have? C2H6. Does anybody have an extra C2H6? Please look through your stuff. Yeah, there's one missing here. I know, but is that the only one you have? Okay, I'm gonna bring it back. Here, y'all use that.
You got an extra 3.
Okay, we do have a group back here that got the last equation. You have to keep working with it. It took y'all a while, didn't it? Yeah. Okay, let's do the H's. We have a 6 over there. What are you going to have to put here? Get 6. You're going to have to put 3.
She goes like this.
Now, let's get
There.
how many oxygens does that make? That's 2, 5. You're going to be able to get 5.
All you gotta do is squat.
So, that's going to be wrong.
Good. Good. How much I'll do a squat? Yeah, I did 40. I did 45 in each one.
Put it 2 on that.
I do 45 pound plates on each side for squats.
That's 12 hydrogens. So what are you going to have to put there? 12. Put a 6 here, please. Now, 6. That's 6 times 4 is 12 down there. How many oxygens? 10.
This stuff is
2 times 2 is 4. 6 times 1 is
Wouldn't it be
Okay, I'm going to start going through the answers here before we run out of time. I want you, yeah. No, wait, that's right there. Okay, go ahead and put the cards back in the bag, please, and we're going to go over the answers here. The next equation was H2O2 yields H2O plus O2. Go ahead and get the cards in the bag. I'm going to wait for y'all, and then I want you to check your answers again. Wow. Okay, put the cards. We will have to go over this tomorrow. Make sure you. Bring me the cards. No, keep it. Unless you're afraid you're going to lose it, then put it in the box. Yeah.
Get over your little.
Thank you. Bring the Ziploc to me when you're finished.